Now, next topic is ammeter. Ammeter is a low resistance galvanometer. Low resistance galvanometer, and it is used to measure current. It is used to measure current. So ammeter is a device which is used to measure the current in a circuit. So if we connect a low resistance across the galvanometer in parallel, and that low resistance is called shunt. So if total current across the circuit is I and Ig is flowing across galvanometer, as it is clear from the figure that current is going along two paths, so it will divide. So if Ig is going across this path, then I minus Ig is left, and that will flow across the shunt. Now both are coming to a single path, so total current is again I. And in parallel, potential is same. So Vg is equal to Vs, and according to Ohm's law, potential is current into resistance. So Vg is Ig into G, and Vs is I minus Ig into S. So I am calculating formula of S, that is Ig into G over I minus Ig. So this is the formula of the shunt. Okay. Now I am finding here net resistance of the circuit. Net resistance. Net resistance, as it is clear from the figure, both are connected in parallel. So in parallel, you know that formula is 1 by R1 plus 1 by R2, that is 1 by G plus 1 by S. So by this method we may find, and RP becomes here GS over G plus S. So this is the formula of the net resistance in parallel. And now I am talking about the ideal ammeter. As you know that ammeter is a low resistance device, okay, and that is used to measure the current. And now ideal ammeter will have zero resistance. Okay. So this is the value of the resistance of ideal ammeter. Now, question related to ammeter is an ammeter of resistance 0.8 ohm. Ammeter means it is a low resistance galvanometer. So galvanometer resistance is given, that is 0.8 ohm. It can measure the current up to 1 ampere. It can measure the current up to 1 ampere, and first part is what must be the shunt resistance to enable the ammeter to measure the current up to 5 ampere. So it is a galvanometer and the resistance is this, and this galvanometer can measure the current up to 1 ampere. So galvanometer current is 1 ampere. And what must be the shunt? So we have to find the value of shunt to enable the ammeter to measure the total current up to 5 ampere. And you know that formula of shunt. What is shunt? IgG over I minus Ig. What is Ig? 1 ampere. Galvanometer 0.80. I minus Ig means 5 minus 1. So now shunt becomes, that is 0.8 over 4 means 0.20 ohm. So this is the value of the shunt. Now next part is what is the combined resistance of ammeter and the shunt. As you know that for making ammeter, a shunt is connected in parallel to the galvanometer. So net resistance is 1 by G plus 1 by S. 1 by G plus 1 by S, and this Rp is Gs over G plus S. So what is G? G is 0.8. What is S? S has become, that is 0.2. And G plus S means 0.8 plus 0.2. So it will become 0.8 into 0.2 means 1.6 0.16 over 0.8 plus 0.2 means 1. So answer is 0.16 ohm. So net resistance of the circuit is 0.16 ohm. Now next topic is voltmeter. Voltmeter is a high resistance galvanometer. High resistance galvanometer, and it is used to measure the potential difference. Used to measure potential difference in a circuit. So it is a high resistance galvanometer. And you know that how high resistance is obtained if we connect a resistance in series. So if we connect a resistance in series with galvanometer, then this complete circuit is voltmeter circuit. Now if total current of the circuit is I, or you can write it as Ig. So V is equal to Ig into G plus R as per Ohm's law, and this R becomes now V by Ig, cross multiplying it, minus G is equal to R. So this is the formula for the resistance which we will connect in series with the galvanometer. Now formula for net resistance of the circuit is, as both are in series, so it is R plus G. So by this we may find the net resistance. And now I am talking about the ideal voltmeter. Ideal voltmeter, as you know that voltmeter is a high resistance galvanometer. Okay, so if we talk about the high value of the resistance, means ideal voltmeter has infinite resistance. So this is the resistance of the ideal voltmeter. Now we will do a numerical related to this topic. That is, a question is, if a galvanometer with a resistance of 12 ohm. Question is, a galvanometer of resistance 15 ohm, 12 ohm, shows a full scale deflection. Shows a full scale deflection. Full scale deflection for a current of 2.5 milliampere. For current of 2.5 milliampere. How will you convert into voltmeter of range? How will you convert into voltmeter of range 7.5 volt? 7.5 volt. So question is a galvanometer of resistance. Galvanometer resistance is denoted by G, and that is 12 ohm. It shows a full scale deflection for the current. So galvanometer shows the current of this. So it is the current of galvanometer, and that is 2.5 milliampere. How will you convert into voltmeter? So how will you convert the galvanometer into voltmeter? By connecting a resistance in series with the galvanometer. It means we have to find the value of that resistance. Okay. So we will find the resistance that we have to connect in series with galvanometer. And range of this is, that is the maximum limit of the voltmeter is 7.5 volt. Okay, so as you know that formula is R is equal to V by Ig minus G. So I am putting the values here. 7.5 over Ig means 2.5, milliampere means 10 raised to power minus 3 minus 10. So by this you may find the value of R. Okay, so that will become, that has become 3000 minus 12. That is 3000 minus 12 means 2988. 88, yes. Okay. Now this is the resistance which we will connect in series with the galvanometer, that is of 2988 ohm. Now if question comes that find the total resistance, then for total resistance formula is R plus G. R is 2988 plus G is 12, that is again 3000 ohm. So this is the total resistance of the circuit. So by this method and by using these formulas, you may find the value of the resistance which we should connect in series with galvanometer.